Trigonometry, Chapter 5, Trigonometric Identities, Section 1, Fundamental Identities, Video 9, Simplifying Trig Expressions, Example 2. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. We're going to simplify another trig expression. We're going to rewrite in terms of sine and cosine, then simplify the expression until no quotients remain and all functions are of theta only. Or are we? You know, it's interesting because the instructions on some of these say to do something specific, then do something else. For example, these say rewrite in terms of sine and cosine, then simplify. Well, when you're simplifying a trig identity or simplifying a trig expression, there's almost always one of two options to consider. Option number one is to do some sort of algebra move. Option number two is to do some sort of trigonometry move. So what are our options here? Well, algebraically, we could do a FOIL process. We could do first, outside, inside, last, and then see what happens. Trigonometrically, the only option that I can see is possibly to take this sine of theta and rewrite it as 1 over cosecant of theta. But then what would we do? Probably some sort of foiling again. So our options are do algebra first, where we FOIL and then see what to do trigonometrically, or do trigonometry first and replace sine with 1 over cosecant, and then do algebra. Would I rather do algebra before I put a fraction in or after? I think I'd rather do the algebra before. So despite the fact that this says to rewrite in terms of sine and cosine, then simplify, I'm going to distribute first. So let's multiply this out and see what happens. 1 times 1 is 1. 1 times negative cosecant theta is negative cosecant theta. And on the other half of the distribution, positive sine times 1 is positive sine. Then positive sine times negative cosecant is negative sine theta cosecant theta. And at this point, there's really not much more algebra to do, but we can do some trigonometric moves. Now, speaking of trigonometric moves, we can still replace cosecant with 1 over sine. And you would think the instructions say to do that explicitly. But is there a benefit to changing both of them? If we change the first one to 1 over sine, then will that really get us anything? Actually, it'll be counterproductive because if we change the first one to 1 over sine, 1 second. If we change the first one to 1 over sine, well, let's just go ahead and change them all. If you're not sure, just do it. You may be doing moves that you don't need to do. Let's turn this cosecant into 1 over sine. Now, as a consequence of the second one, we can cancel the signs and we're left with a -1, so that's good. But is there any benefit to that first one? And I would say no, there's not. So as a consequence of that, I'm going to go back and undo that. Was it wrong to do it? No. Well, depends what you mean by wrong. It said the instructions say simplify until no quotient remain. Well, quotient is a fraction, so creating a fraction here on the first cosecant and not doing anything with it is counterproductive to the instructions. However, converting the other cosecant, oops, wrong color. Let's fix that. Converting the other cosecant, highlighter, yellow, into 1 over sine was productive because it allows us to cancel that sign there. So we are going to go with the flow and see what happens here. Okay, after converting the second sign, after converting the second cosecant into 1 over sine and canceling, we're left with 1 minus cosecant theta plus sine theta minus 1. Well, the ones cancel, so that's good. And we're left with negative cosecant theta plus sine theta, which is a perfectly acceptable answer. But when you're writing a sum or a difference and one term is positive, one term is negative, it just looks cleaner to put the positive one first. But the best answer to simplifying this expression is sine of theta minus cosecant of theta. We've done all the algebra we can. There's no quotients, and of course, this is a function of theta. So just because you can rewrite stuff in terms of sine and cosine doesn't mean you should. If there's a reason to do it, do it. But if doing it makes nothing happen, like the first cosecant just sitting there as 1 over sine, then by all means, don't do that move.